it's worth taking a little time to discuss why human-caused climate change is a problem. It is true that politicians and the public are still debating whether we humans are causing global warming, whether global warming is happening, whether it's really fossil fuel burning that's doing it. But the fossil fuel burning, releasing CO2, changing the atmosphere, changing the climate, affecting us, is really undeniable fact now. So let's take a little bit of history. We'll start over here in 1800 and run through today with a timeline and look at a few events, some of which are connected to my cell phone and its development. So in the year 1900, Planck introduces quantum mechanics. And you know that the computer in my cell phone is designed using the principles that come out of our understanding of quantum mechanics. In 1905, Einstein introduces the first part of relativity, special relativity. My cell phone has a GPS in it, and the GPS is using both special and general relativity because the satellites are higher in Earth's gravity well, going faster than we are. And it works, this is all wonderful things. In 1915, Wegener introduces his ideas on continental drift, and we geologists use our understanding of continental drift as one of many ways to help us find ore deposits that go into getting the things that you use to build the cell phone. Now, the cell phone has a nice person in there. There's a lady's voice that tells me where I am, and she is using filters to hear the signal from the satellite. And those filters are based on mathematical work that was done by the great French mathematician Fourier. In the year 1824, Fourier started calculating the balance of energy for the Earth. And he said the simplest model leaves us colder than we really are. But the simplest model has to be about right, so something else must be going on. And he suggested that there's something happening in the air that warms us in a way that's similar to how a glass plate on top of a sunlit box will keep that box warmer. And we now call this the greenhouse effect. So Fourier introduces the greenhouse effect in 1824. The role of CO2 was first identified by Eunice Foote in the U.S., and then there's a lot more work done on this by Tyndall in the UK, 1856, 1859. The first calculation that's accurate of the warming of the surface that will be caused by humans burning fossil fuels is by Arrhenius in 1896. So climate is not some newfangled speculative thing that's going into building the cell phone that's in your pocket, but it is really long-established science. Arrhenius's calculation was done with classical mechanics. It was before quantum. Our quantum understanding is in many ways based on work that was done by the U.S. Air Force after World War II. They wanted to do communications and operations and heat-seeking missiles. If you're going to target the hot exhaust of an enemy bomber by looking at the infrared radiation coming from it, if you use the wrong wavelength on your sensor, CO2 absorbs the radiation and your missile will not hit the target. And I can tell you today, wherever you are in the course of the day, there will be more infrared radiation going up from the sun-warmed Earth than coming down from enemy bombers. And some of that radiation is absorbed in the atmosphere. Before we ever had satellites, the physicists predicted what those satellites would see when they looked down and how it would change over time. And those predictions have been successful. So that blue line is following the predicted and observed radiation going up from the sun-warmed Earth to be seen by satellite. In fact, that has changed over time as we've changed the atmosphere and the temperature of the Earth. So it's up just a little bit. There's 2 lines on there. But maybe the most important thing here is that huge divot is energy that is kept in the Earth's system because CO2 absorbed it. And if we have more CO2, more can be absorbed. You meet the person who says, "Oh, I don't believe in this." They don't believe in the ability of the Air Force to build a heat-seeking missile. This is physics. We raise CO2 in the atmosphere. That has a warming influence. It's just physics. It is successfully predictive. And I'll show you just a little bit of a vast amount of data. Here's a plot starting in 1880 and coming up towards the present of different temperature records developed for the surface of the Earth by different groups with different funding, including one of these groups that started from a physicist who sort of didn't believe that the other scientists had done their job right, got money, including private money, to demonstrate that the temperature records weren't good, and the temperature records were beautiful. This one shows that sometimes even a little more warming than the others, but you can see all of the data agree with the temperature wandering up rapidly because we're driving it up. Now, that's thermometers. If you simply restrict yourself to thermometers that are far from cities, they also show the warming. Thermometers placed in the ground show that the ground is warming. Thermometers placed in ocean water show that the ocean is warming. Thermometers taken up on balloons show that there's warming above the surface. Thermometers looking down from satellites show the warming. If you look at temperature-sensitive snow and ice, not South Pole. I've been to South Pole. It's -50. If it warms up to -40, it won't melt yet. But if you look at the temperature-sensitive ice, springtime snow, lake ice, river ice, sea ice, temporary frozen ground, permafrost, permanently frozen ground, which is now not frozen, and places, the mountain glaciers, the edges of ice sheets, all of these are being lost with warming. If you ask plants and animals where they're living and when they do things, the vast majority of the shifts are in the direction you expect from warming. So as early as the 2007 UN report, warming in the climate system is unequivocal. Now, how do we know that the warming that must happen from the CO2 is what is driving the warming here? Well, we've looked very hard for other causes. No, the sun has not brightened over the time we're looking at. It wiggles a little. Nothing else is going on to drive this, and the CO2 predicts it beautifully. So this plot, which comes from the director of the NASA Goddard Institute for Space Studies, has on it both data and model output. And it starts over here on the left, where the models have been told about things like the particles from volcanoes blocking the sun and making that little cold divot there. That was Mount Pinatubo. And then it runs into the future. We don't know when the volcanoes will erupt, so there's nothing put on there. But there haven't been any really big volcanoes in this interval, so that there's not a huge volcanic influence. What the models say is that our CO2, the other changes we're making, but mostly CO2, will drive warming. Every model run has in it some variability from things like El Niños, but more than a few years in the future, you can't predict El Niños exactly. It's like predicting the weather exactly. And so what's happened in this plot is the models have been averaged to give the black line. And what you should expect is the black line plus a little bit of wiggling from El Niños. What then happened after this was predicted is just what was predicted. This is successfully predictive for the warming, for the pattern of the warming. The stratosphere cooling as CO2 holds heat down here, more warming at the Arctic, more warming on land than the ocean, and other sorts of things. The pattern, the amount of warming are indeed being successfully predicted, and we know this now. This is a particularly interesting one. It starts further back in time. It goes further into the future than we've gone. On here are projections and predictions and actual data. And this happens to be scientists who are working with or for or funded by oil companies. So each of the gray lines starts at some time well in the past. That one was way back. Others are a little closer to today. And each one of them is one of these. This is what we'll get if we keep burning fossil fuels into the future for an oil company. And then the red is what happened. This works. It really, really, really does work. The science is solid. We are driving this. The warming effect of our CO2 is not the least bit surprising. But what is surprising, Arrhenius said, I don't think we'll burn that much fossil fuel. That was what's really surprising, is how good fossil fuel companies have been at getting us what we burn. There's a comparison here. You know what trash looks like. You've taken out the trash for your parents, maybe, or done it for yourself, or tried to get kids to do it for you. In the U.S., we throw away at the curb for the trash collector a half a ton of trash per person per year. In the U.S., averaged over sort of the early part of the 21st century, was about 16 tons of CO2 per person per year. That's dropped a little, maybe even a shade below 15 now, but it's still 15 tons per person per year. And it is changing the climate.